Hello guys, welcome to lesson 2, your second screencast. In this one we'll be learning about how to do operations with the square roots. So as a review, let's go ahead and do this. What we really need to know, we need to know about how to factor with perfect squares. Remember, your perfect squares are numbers like 36 we saw last time because it was 6 times 6 will give us 36. So 36 is a perfect square. 25 is another perfect square. 81 is a perfect square. 9, 100. Anytime you can take a number and multiply by itself, that result will be a perfect square. 3 times 3 is 9. So 9 is a perfect square. So here what we want to do here is to factor these numbers, but they need to have a perfect square in there. So go ahead and try that and then pause and then come back and get the answer. Okay, well, welcome back. Let's see how you did. So 18 we can factor out. So here we have 2 times 9. Why we have 9? 9 is a perfect square. So that's good. Number 2, 3 times 25. 25 is a perfect square. That's great. 4 times 14. Now 4 is a perfect square. That's good. And 2 times 49. And 49 is a perfect square. 7 times 7. 5 times 5. 3 times 3. 2 times 2. So those will have perfect squares in their factors. Alright, so let's go ahead and start with the actual lesson. So we'll be learning on how to perform operations on real numbers, including radicals, which is what we're dealing with now. Okay, here are our vocabularies again. So we have a radical symbol, which you already know what that is. Radical expression, and now we have radicand. Okay, new word you do not know is the radicand. The number below square root is called the radicand. So put that in your notes. Okay. The number that is right below the little square root symbol, that's called a radicand. Okay, so here we need to go ahead and to simplify these. Now, in your previous class, they probably taught you about how to combine like terms. So here we will be trying to solve 3 times the square root of 6 plus 4 times the square root of 6. So what we can do here is exactly, since they're both the same, the radicand is the same, so we can just go ahead and add them up. Okay, so this will be 3 plus 4 times the square root of 6. And 3 plus 4 is 7 times the square root of 6. So we just take this big expression here. This is called the radical expression. We just take the radical expression and we just made it into a very simple one. Okay, so once again, I was able to put them together, to combine them, because the radicand is the same. If for example this was 3, 6 plus 4, let's say, then I will not be able to just do 3 plus 4. Okay, I'm only able to do this because the radicand here is the same. Alright, here's another one. So I have here 2 times negative 7 plus 9 times negative 3 minus 8 times negative 7. So what I'm going to do, oops, I see numbers that look the same. Okay, square root of 7, square root of 7, good. So what we are going to do is to commute them. We're going to commute. I hope you guys remember the commutative property means I'm just flipping the numbers around. So I'm going to move negative 8 times square root of 7 with this one over here. So 2 times the square root of 7 minus 8 square root of 7 and then plus 9 square root of 3. Please make sure that when you commute, the negative symbol in the front of the number belongs to the number behind it. So this is not just 8 square root of 7. This is negative 8 times the square root of 7. Okay, and then now I can actually go ahead and combine these. So this will be 2 minus 8 times the square root of 7 plus 9 square root of 3. And then 2 minus 8 will be negative 6 times the square root of 7 plus 9 to the square root of 3. Now, if you notice, there's nothing else that I can do here. Why? Because the radicands here are different, so I cannot combine them. It will be like combining apples and oranges. Okay? So we cannot combine them together. So again, let's go ahead and recap. First thing we did was commute. Negative 8 square root of 7, move it with a 2 times square root of 7. And then, like the first example, we just go ahead and, in this case, subtract them. 2 minus 8 times the square root of 7 plus 9 square root of 3. 2 minus 8 is negative 6. Don't forget about your sign. Square root of 7. Okay, here's another example. This one will be very easy. Go ahead and try it yourself. Pause. Come back and get the answer. Okay, welcome back. So here, this says the radicand here is the same. We can just go ahead and add them. So this will be negative 3 plus 2. Okay, in this case, that is going to be negative 1, and we want to keep the negative sign. It's negative 1. Remember, in math, we do not like to write the ones. They're invisible. So this is negative 1, but we just put negative square root 11. Alright, go ahead and try this one by yourselves. Okay, so here okay, let me go ahead and explain this one. Okay, what is going to happen here? We have negative square root of 14 and positive square root of 14. If you guys remember when you learn about integers, a plus and a minus, those guys are neutrals and they will cancel each other out. Okay, so it was like saying if I have negative 2 and then I add 2 to it, I'm going to get 0. Right? So same case here. If I have negative 14 and I add positive 14, these guys are going to cancel each other out. So I'll be left with 4 square root of 15. Okay, that was very easy, but it looked complicated. Okay, so now we are moving on to using the distributive property to simplify the square roots. So copy this down in your notes. So in words, we have the product of square roots is equal to the square root of the product of the radicands. Okay, and then for all numbers we have that is more than 0, and all number b that are more than 0. If we have square root of a times the square root of b, we can combine them and put them together. Okay, we did that before. So here we have square root of 9 times the square root of 4. We can just combine them together and do square root of 36, and we get 6. Alright, so here's one. So what we want to do here is combine them together. Switch to pen. So we can just put them under one big umbrella. So 18 times 8 is 144. So that'll give us square root of 144. And of course, we all know square root of 144 is 12. Oops. Alright, square root of 144 will be 12. Okay, very easy, right? A caveman can do it. Okay, next one. Alright, try this one by yourself. Alright, so here's the answer. Again, what we want to do here, this is, we want to put all the radicands under one umbrella. So this will be 4 times the square root of 20 times 20. Okay, so that will be, in this case, that will be 20, but doing the steps, so that would be 4 times the square root of 400, and that would be 4 times the square, and the answer here will be 80. Okay. Whenever you have the same radicand and it's also being multiplied by itself, you're going to get that same radicand back. So it's like if I have square root of 25 times the square root of 25, that answer would be 25. Okay, so we could have skip this step, but I just wanted to show you guys. Alright, go ahead and try this by yourself. Come back and get the answer. Make sure you guys are doing the practice as we go along. Alright, so again here we want to put them under one big umbrella. So this will be square root of 5 times 20, which is square root of 100. And that will be 10. Very easy. Alright, let's go on to the next one. Okay, so here we have square root of 2 times 2 square root of 2. Okay, what did I tell you guys? Whenever you see the exact same radicand under the square root, the answer will be that number. So I already know square root of 2 times the square root of 2 is going to be 2. Then I know it's 2 times 2, which will be 4. Okay, I hope you guys saw what I did. Any questions? Post them on Modo. Okay, so here we are going to go ahead and simplify this one. Now the whole, remember the little warm-up you guys did trying to factor out the numbers? So that's, now it's going to come in handy. So here I have square root of 162. Oh my god, 162 is not a perfect square. It's not like 6 times 6. It's not like 36 or 25. So first thing, so what I want to do is to factor this out. What two numbers when I multiply will give me 162? But I'm going to try to get one with a perfect square. So I know 2 times 81 is 162. So I'm going to put square root of 2 times 81. Okay. Now I know square root of 2 is not a perfect square, so that's going to stay. Square root of 81 is 9. So I'm going to take this one and bring it out. So square root of 81 is 9 and square root of 2 stay. So this will be my answer. This will be this square root simplify. Okay. So once again, recap. We had square root of 162. What we did was break it down into perfect squares. So get down into perfect squares. So here we have square root of 2 times the square root of 81. Let me break it down. Maybe it will be easier to understand. And then square root of 81 is 9. And square root of 2 stay because square root of 2 is not a perfect square. It's irrational, actually. It keeps going and going and going, never stop. Alright, go ahead and try to break this down. Come back and get the answer. Okay, so here we have square root of 180. So we want to go ahead and try to break it down where we have perfect squares. Okay, so when we factor 180, we can use 36 times 5. So this will give us 36 times 5, and square root of 36 is 6, square root of 5 is staying. Okay, try this one. This one might look complicated, but it's not. So what we want to do here is to break down the square root. So 7 square root of 5. This is already in simplified form. So let's go ahead and simplify this. Let's deal with this one only now. Let's take it out here. So if I factor it out, so I will get square root of 25 times the square root of 5. Because 5 times 25 is 125. So this will be square root of 25 is 5 So this will be 5 times the square root of 5. So now I can put this here for square root of 125. So this will be minus 5 square root of 5. Now that they both have the same radicand, I can just go ahead and subtract them. So 7 minus 5 is 2 square root of 5. Okay? Alright guys, I'm going to go ahead and stop right there. That's it for today. We'll do more of these practice in class. So please make sure you guys are posting questions on Edmodo, and so that I can help you as you go along. Your classmates can help you. And I'll see you guys next class. Have a good one. Bye-bye.